Okay, we take a look at number 3. I'm going to make this full screen for us. Airline offers these advanced purchase tickets, or advanced purchase fare tickets, and then it's going to take a look at some no-show rates. The first thing that I would suggest here, I don't see the word both popping up. I don't see a lot within the word problem that's going to help me out. So my first suggestion to you is go ahead and turn these into probability statements. So 60% of customers take advantage, which means that the probability that they get the advanced purchase, that looks like 60%. Now we have to translate this, the no-show rate among people who paid regular fare. In other words, we know that they've paid um, a regular fare. So the way that I'm going to look at that, we know that they have not done the advanced, and the probability they don't show up, right? No show that they don't show up is 30%. And then we also have this 5%. We know that they did take advantage of the advanced purchase ticket, but they also did not show up. So the fact that all of a sudden this last sentence turns things into conditional probabilities leads me right down this road of some type of tree. Right? When I see conditional probability sitting here, I'm going to go for a tree to organize this data. So the very first place where we can split it, as you can see here, the no-shows and the ones that did show up are coming out of the advanced purchase tickets. So either someone made the advanced purchase or they did not. And then from there, they either show up for the flight or they don't show up for the flight. I'm actually going to make this a little bit bigger so it'll be easier for me to read. So advanced tickets, non-advanced tickets, and then they show up or they don't show up. They show up or they don't show up. All right, so fill in some gaps here. So the probability they get the advance ticket was 0.60, which means 40% of people do not purchase advanced tickets. And then the probability they did not buy the advanced and do not show up would be 30%, which means 70% of people don't buy advanced and do show up. 5% of people have purchased and are no-shows, which means that 95% of people fall into the advanced tickets and show up. So it looks like it's a lot more likely somebody actually shows up for the flight when they buy that advanced ticket. Now, my suggestion to you is to go ahead and fill in all the gaps here at the end of the tree. So this would be 0.57, 0.60 times 0.05, 0.03, 0.4 times 0.7 is 0.28, and then 0.4 times 0.3 is 0.12. And again, if you do all the ends of the branches, we should add up to 1. So now that we got everything organized, let's pick through this and come up with some answers to these questions. So what percent of all ticket holders are no-shows? So what's the probability that we get someone that doesn't show up? Well, there's 2 ways that somebody could not show up. It's either going to be right here or right there. So advanced tickets no-show or not advanced and no-show. So that would be, they could either buy the advanced tickets and not show up, or they could purchase regular tickets, right? This word is or, and not show up. The beautiful part about setting the tree up already is we've got the numbers sitting at the end. So that would be 0.03 plus 0.12. There is no overlap. So 15% of all ticket sales or ticket holders don't show up for their flight for whatever reason. What's the probability that a customer who didn't show had an advanced ticket purchase? So here's a question on some conditional probability. Read carefully. What's the probability that a customer who didn't show up? So we know they didn't show up. They did not show up. What's the probability they had an advanced? Right. So we know in Part B that they didn't show up. And then we're going to see out of those no-shows who did have that advanced purchase ticket. So that would be advanced and no-show over the probability of no-show. Well, advanced and no-show is sitting up at the top at 0.03. And strangely enough, again, there are two ways for no-shows. Two ways for no-shows. And Part A actually already got us the probability of a no-show, and that was 0.15. So 0.03 divided by 0.15 is 0.2. So about 20% um, of people that didn't show up were advanced purchase folks. And is being a no-show independent of what type of ticket? Well, again, that independence is based on a conditional probability. We just did a conditional probability, so let's take advantage of it. The probability of advanced and no-show, um, well, it's a little bit different here. We'll just work this thing all the way out. We'll go to the probability of advanced given that they show up. And that should be equal to the probability of an advanced purchase. So advanced given that they show, this would be the probability of advanced and a show over the probability that someone showed up. Going back to my tree, advanced and show is 0.57. And then the probability someone showed up, there are two different places where showing up for the flight, right? There's a show, and that would be 0.57 plus 0.28. Because again, take those values from the end of the branches. That way we've set ourselves up for a lot less work. And that probability is 0.67. Alrighty. And then the probability that someone purchased the advanced ticket was 0.60. These two things are not equal, which means they are not independent. And the previous part of that question, if you look back, it says explain. Well, by doing all this work, showing the conditional probability is not equal to the just probability of advanced, we've explained our work by working through that all the way. All right, so very quickly, number 4. This battery company produces batteries about 5% are defective. So you start getting batteries, and we're going to find the probability of the outcomes. So part A, what's the probability we get 2 good batteries? So that's a probability of good and good. Right? Here, each battery will be independent of each other. This is a safe assumption. The fact that we pick one battery out of a box, out of a batch, is not going to affect whether or not the next battery is. So the probability of a bad battery, I think it just said, is 5%, which means the probability of a good battery is 0.95. Right, so there's our 2 probabilities. So good and good would be 0.95 times 0.95. And that would come, that'd be about 0.90. All right, at least one of the first 3 batteries are good. Here's that at least one, and this would be a great opportunity to do 1 minus the probability of no goods, or all bad. Right. So here it'd be 1 minus bad and bad and bad, right? So the bad one, 0.05, 0.05, right? So this would be bad and bad and bad. And just a second, my calculator, I have the wrong thing. This is about 0.9999. first four you pick all work, that would be um, good, and good, and good, and good. And that would be, right, so 0.95 times 0.95 times 0.95 times 0.95. And that is 0.81. That's about 0.81. And then finally for part D, what's probability you have to pick 5 batteries in order to find one that doesn't work? So in other words, you get a good battery, and a good battery, and a good battery, and a good battery, right? That's 4, 1, 2, 3, 4, and the fifth one is bad. So really, I'm going to take advantage of the work I just did in part C. 4 goods in a row, right? 4 goods in a row is right above us at 0.81, and I'm going to multiply that by 0.05. So 0.81 times 0.05. Um, the probability that we get this particular order is 0.04.